Well, today I want to speak about the possible implementation of Skyway technology for the Thailand Eastern Economic Corridor. First of all, I want to speak about the technology itself, so that you would know how it works, what that's like. Then I want to speak about three possible applications, three possible solutions which can be used here in Thailand. And I want to finish with the conclusions and the effect which it can bring to the economy of Thailand. Well, first of all, what's Skyway? It's a transport system which is situated at the second level, which has several advantages, which are it is fast, the speed is up to 500 kilometers per hour, it's safe, it's ecologically sustainable, it's easily accessible, and it's comfortable. And now I want to show you a small video, so you will see everything by your own eyes. And I want to attract your attention to the fact that everything which will be shown is not a computer graphics, but it's a real video which is operating in our Air Park in Belarus. I hope you enjoyed our video. Well, now I want to speak a bit more about the advantages of our transport system as it differs from the conventional transport. First of all, we have quite low capex. You may see at this graph that our capex is at least twice less compared with most of conventional transport, and if we compare with monorail, with light metro and Mandev, it's could be 10 times less. And the main idea is that we use very light but very rigid strain rail, which is based on the pre-stressed strings, which are put into concrete. That's why we get a light but very solid structure. That's why it's less material, it consumes less material, that's why it's cheaper. Further on, we have minimal operating expenses. If we compare with the conventional transport, we can see that the most part of the cap of OPEX is labor expenses and cost of fuel. In our case, it's the least part. And our transport is driverless, so we use automatic control system. I will speak about that a bit later. And in general, we can get the effect of so our transport system is 2 to 5 times cheaper in terms of OPEX compared with conventional transport. The next point, it's our transport system is ecologically sustainable. So we use minimal landed resources, and we use electricity, so it minimizes the harmful emissions to the atmosphere, and lots of people like that. And the last point is safety. The main issue here that our transport system is situated at the second level, so it doesn't cross with the existing transport at all. so the traffic accidents are minimal. The second point is anti-derailment system. You can see it in the picture. So it also increases the safety of our transport system, and it's resistant to natural disasters. The previous speaker was saying about floods here, and actually it's also resistant towards earthquakes, tsunami, and other natural disasters. So this transport system won't be ruined if any natural disasters happen. Well, and actually now we are implementing that at our test site in Belarus. We call it Eko-Technopark. It's situated in the town of Marina Gorka. It's not far from capital city of Minsk. And here you can see all the main types of our transport: unibus, unibike, unica. I'll speak about them a bit later. And actually, you may also see that we have got, at the end of the previous year, of the year 2017, we've got certificates from the Russian Institute of Urban Transport. That's why these vehicles are not just operating, but they are certified. Well, and now let's think how this project, how our technology can help to the development of Thailand, and in particular for the Eastern Economic Corridor. Actually, you can see this map, and actually the main points here to connect the seaports and the airports into one integrated transport system. And what we can do here? Well, first of all, we can increase cargo turnover, we can reduce transportation costs, we can increase the convenience of the transport, we can minimize transportation time, because the speed of our transportation is up to 500 kilometers per hour, and we can promote tourism as well. Well, and now let's speak about our main solutions which could be applied here. First of all, it's cargo transportation. So, if speaking about Skyway transport system, it has several advantages. It's autonomous, it's point-to-point, it's high speed, it's ultra-safe and energy efficient. We have also special solutions, not just for cargo transportation, but for the seaports as well. And many people during this conference were asking exactly about these solutions. You can see at this picture how container transportation could be arranged along the water, for example, and it can combine container transportation at the upper level and passenger transportation at a lower level. So it's a universal transport system. And also we can make offshore ports, so that we put it into the sea and put the storage places into the ground. So we leave the shore of the sea free of any infrastructure, so it can be used for recreation, for some other economic activities. So, but we don't need to put boats at the shore, and these solutions could be applied not only for the big ports of world importance, but also for the small ports, as you can see at this slide. And here you can see how our container transportation could work. So the speed is up to 500, about 50 kilometers per hour. It's automatic loading and unloading. Its performance could be up to 30 million containers per year. And we can use track, as I told already, for passenger transportation. And we have different solutions, not only for containers, but also for bulk, break bulk, and liquid cargo. This is our cargo module, which is called unit truck. It's arranged for a small amount of cargo. It's for bulk cargo, actually for 1.8 metric tons. But if we if we place them one by one, it can carry quite a great amount of cargo. We consider the performance of such system about 100 million tons per year, even despite it looks so small. It's already operating at our Eko-Technopark, So you may see it in the video. And we also have solutions for loaded and unloaded terminals. And I think that all these cargo systems could be integrated, and it could integrate the airports and seaports into unified transport system. Well, the next solution which I want to speak about is high-speed passenger transport. As I told already, it is up to 500 kilometers per hour. It's bigger compared with conventional high-speed trains, and it can be used to unite cities, regions, countries, and even continents. Here I give at the map, I give the possible example how it could be applied for the case of Bangkok. For example, we can connect Bangkok with Kuala Lumpur and Singapore. And yesterday we were discussing the project Kuala Lumpur-Singapore. I think this solution could be also applied for this project. If we compare Skyway with other types of high-speed transport systems, you can see that almost all the parameters which are construction cost, OPEX, accident rate, and environmental impact, we are better. Maybe the only point where we look a bit worse compared with aviation is speed, but we should take into account one point. If you go to the airport, you anyway need to wait for boarding, to stand in the queues, to pass control, and actually you have to add 3-4 hours to the time of your trip. In our case, we get from the city center or city suburb exactly to the city center or city suburb, and actually you will get, for example, if you go for 500 kilometers or for 1,000 kilometers, you will get to the place of destination faster. And these are technical parameters for our high-speed minibus. It's designed for 10 people. Its design speed is 450 kilometers per hour, and its performance is about 7,200 passengers per hour. And the last point which I want to speak about, the last solution, is urban passenger transport. First of all, I want to speak about Unibike, which is some kind of PRT designed by our company. It's designed for 2 persons, but there could be solutions from 1 to 5 persons. And it can be used as a sightseeing vehicle. For example, it could be, I think it would be really great to go by Unibike to safari, for example, or to see some natural places from the bird's eye view. And also, I can say that it can be used also as a standard urban public transport. The idea here is that we just put it one by one, and so they can carry quite much passengers. I show it later. Well, these are main technical parameters of Unibike. Its weight just about 80 kilograms, about 800 kilograms. It can carry 2 persons, and please pay attention to the energy consumption. Actually, even at a speed of 150 kilometers per hour, it consumes just 1.7 liters of equivalent of fuel. It's electricity, but as equivalent of fuel is just 1.7 liters, much less compared with standard automobile. And this is carrying capacity. I want to show that it's not just recreational type of transport, but it's also could be a transportation system. So you can see that this type of transport could carry about 150,000 people per day. I also want to speak about the other solution, which one is Unibus, which is full-fledged solution for urban and intercity transportation. So this is actual possible replacement of metro, buses, and any other types of transport. So if you look at the graph, you can see that the difference of this. You can see that the speed of our transport is much higher. It could move at a speed of about 150 kilometers per hour, and the average speed is about 80 kilometers. So you can, maybe you've already tried how it is in Bangkok. Actually, there are lots of congestions all over the roads, and it's quite difficult to get where you want in time. So by using Unibus, it won't be a problem. You will get wherever you need quite quick. And actually, as we see, it could be used here for urban transport system in Bangkok and in the city of Pattaya, for transportation system connecting Bangkok and Pattaya, because now, as far as I understood, it takes from 2 to 3 hours to get there. By using this transport, you can get there by 1 hour. It would be much more convenient, and it could, of course, boost the tourism here. And we can use it not only for these routes, but also for general intercity transport system connecting the entire region. So if we do that, everything would be operating. It would be a general system which unites all the points. These are main technical characteristics of Unibus. As I told already, it's designed for 14 persons. And one more interesting fact, which is energy consumption. Actually, if it will move it will go at the speed of 100 kilometers per hour, and for example, if it uses air conditioner, then the energy consumption for 14 persons will be just equivalent of 3 liters of fuel. So it's even for 14 persons, it's much less compared with traditional car. And I forgot to say that its performance could be up to about 50,000 passengers per hour. So it's compared with metro. One more solution, which could be interesting both inside the cities and outside the cities, is a second track structure. Actually, it's a solution which replaces conventional bridge, but it's much lighter and much cheaper. So you need not to spend billions of dollars to build some bridges, but this solution could be used. And actually, it's already realized in our Ecotechno Park in Belarus, and anybody can see how it works. This slide is devoted to carrying capacity. As I told already, it could carry about 50,000 passengers per hour and up to 1 million passengers per day. And if speaking about the benefits for urban development, you can see that unibuses can be integrated into any into any urban infrastructure, and actually it can have the following effects. First of all, improve living standards, reduce harmful emissions to the atmosphere, practically no road accidents, increasing of tourist potential, jobs creation, and increase economic potential and investment attractiveness. This slide is devoted to our approach towards infrastructure, and actually some trade and service centers could be played inside the stations. And we also can use our track structure as a place to locate fiber optics and cable power lines. I'll show it in the next slide. So, for example, if we are speaking about some hard-to-reach areas, which I think do exist here in Thailand, you can use this transportation system not just as a transport, but also as a means to provide it with the internet and electricity. And I already told that our transport system is driverless. It's operated by automated control system the main features of which you can see at this slide. So it uses Wi-Fi and other points, and actually it involves both the vehicles and the sports. One more solution which could be applicable here in Thailand. These are Skyway linear cities. You can see at this picture that such cities could be created along the seashore, maybe in mountains, at any place which is convenient for life. And actually you can live in the rural area, but you don't need any car to go to a place of work or place of study or to some recreation, because it is connected by horizontal lifts. And you may use either, you may see the picture, you may use either high-speed trains, which can deliver you, for example, to Ho Chi Minh, to Hanoi, to Kuala Lumpur, to Singapore, and if you need to go to some short distances, you can use the urban transport. And actually, everything is situated in walking distance, so you don't need to use car at all. And I can surely say that this would allow people to live in a healthy area and to enjoy life much more. Well, and now I want to make a conclusion. Well, first of all, our cargo solutions can increase the capacity of ports and freight terminals at least by 20 to 30%, and the cost of such systems are 3 to 4 times less compared to conventional ones. Well, if speaking about high-speed transport, we can connect Thailand with Malaysia and Singapore and other cities as well, and the cost of such track, in my opinion, could be up to 10 to 15 billions of US dollars, which is cheaper than other traditional solutions, especially the Japanese one, I think by 5 to 10 times. And the last point, the urban mobility transport can solve traffic problems in the cities, enhance tourism, and make transportation comfortable and well priced. And the construction of such systems costs less than traditional one by 5 to 7 times. Well, that's all. Thank you very much.